What's going on, my ASVAB party people? Anderson here, your ASVAB coach. Happy to have you here as always. So, if you haven't heard of my classes before, you're in for a treat. We got a 2-hour recording here in this video going over money word problems. So, isn't it already hard enough to deal with decimals as it is? But then on top of that, we got to deal with word problems too. That's what today's going to tackle. I'm going to show you exactly how to keep calm, cool, and collected when you're faced with word problems that aren't formulaic. When it's word problems that you actually have to make a plan start to finish. And then on top of that, you have to give yourself enough time to deal with the calculations with decimals. So that's what this has always been about. It's always been about increasing your score by understanding the little things and doing those little things right. So with that said, if you like the way that this goes for you, after you watch this video, I really implore you to check out my ASVAB All-Access Program. What the program is really the exact way that my students raise their scores and get the jobs they want. Every single time. And the thing is, how we do that is by supporting you every step of the way with classes and the recording, so you don't have to worry about your work schedule or any family commitments you have or family or kids, right? On top of that, you'll have tons of practice problems with video solutions, not like those math textbooks where you leave those confused, more confused than when you went in. And also, you can text me whenever you need help. It comes with tons more features and benefits, but those are the main ones that really give our students the best chances of succeeding. And so if you want to learn more about that, again, there's my number, and there's also a link in the description of this video somewhere that's going to allow you to go ahead and watch exactly how it works. So you can make a decision on whether you think it's worth it or not. And guess what? You can't beat my prices either. The prices are the best you'll ever see. Full stop right there. If you find something better, I'll beat it. And so with that said, I'm party people, let's go ahead and enjoy this 2-hour class, because the point here is to get the ASVAB score that you want and get that military job you deserve. Cheers, and let's taste the ASVAB. Let's go, my party people. So here's the thing. When it comes to word problems, structure is necessary. It is absolutely necessary. So here's the thing. I'm going to use this sort of comparison here. Word problems, and let me just actually set you guys up, really. Everybody, is it true or false to you? Like, would you agree or disagree with this statement that when it comes to word problems versus regular old math, is it fair to say that the only difference between math knowledge and arithmetic reasoning, word problems, is that there's a story overlaying the actual math? Okay, I hope that was fair to say, because it's true. That's really all arithmetic reasoning is. Arithmetic reasoning is essentially a story overlaid the math. Now, that story can be very short, 1 sentence or 2, or it could be 4 or 5 sentences. But nonetheless, there's a story behind the math, basically meaning that you have to go in there and pick the story apart. Now, let me go ahead and show you the right way to pick that story apart. And if you haven't watched my video on the 3 steps to word problem success, I will go ahead and put that video here in the chat box for y'all. So there's that link in the chat box right there. Please, no one type in the chat box for a moment, just for a moment. Don't type anything. If you want, click that video, pause the video, and save it for later. I'm going to teach this to you right here, right now. So here are the 3 steps to word problem success. Step 1, it is not going to be to read the whole problem from start to finish. No. Everybody, think about it like this. Typically, we don't like to watch videos unless we know what the video is going to be about. Typically, we don't open a book and start reading all the way through from page 1 if we haven't at least read the title of the book first, or read what the story is about at least, right? We don't dive into things all in unless we have an idea of what we're going to get out of it. And so this is why when people start reading word problems from start to finish, and you tell me if this sounds like you in the chat box, this is why 90% of the time, new students, what ends up happening is they start reading the problem from start to finish. By the time they get to the 3rd sentence, you're sitting here like, what did I just read? Or you might have been thinking, oh, I saw a 20 over there. I saw a 15 there. Let me just go ahead and add them. Let me see what happens. Let me sing a Hail Mary. Let me multiply them. Let me see if the answer's there. Does that sound like anybody here? So here's the thing, everybody. That is how word problems get you. They get you by trying to entice you to read the story before you know why you're reading the story to begin with. And so that's why step number one, this is cardinal rule number one about word problems. Always read the question first. Your first question when you're tackling a word problem is, what do you want? Right over here. Right over here. I'm going to go and grab green. Step number one is always this. What do I want? What do I want? Pretty much means, what is the question asking you to figure out? So for example, I can give you that same story from earlier. Marcus has the difference of 3 and 2 watermelons, while Cedric over here has 1 more than 0 watermelons. At the end of the day, how many watermelons do they have together? Now, if you would have started reading from the beginning, you're reading 1 less than, the difference of, 1 greater than. If you go straight to the problem, go straight to the question statement, how many watermelons do they have together? Everybody, is it fair to say that if you read that, it sounds like you're just adding up watermelons? If you just start right there at the end. That's the idea. Read the question first. Obviously, that was a very, very simplistic example, but what I'm referring to here is the purpose behind reading the question first basically tells you exactly where you want to end up, where you know you're done. By starting there, that leads into number 2. Once you know what you want, once you know what the goal is, then the next step is, well, what tools do I have in front of me? What information is out there that could potentially help me all day? And sometimes the question even gives you the exact math you need to do, sometimes. And so that's step number 2. What do you have? So by understanding what is it that you want, and then understanding what tools you have, what information you have, that's the greatest thing in the world, because all you have to do now is figure out what the connection is between what you have and what you want. Now, is it going to be instant? Is it always going to pop up in your head like magic? No, of course not. But what will happen is, as you keep practicing this technique of starting with the question, then listing your information out and looking for patterns and connections, you get better and better and better at it. Anybody here who's been in my program for longer than a month and been practicing this technique, has this been working for you? Okay, cool. Those aren't paid actors. Those are people. These are students in the program who truly have adopted that ideology and have gone through it on a consistent basis. This is not something that you want to apply just one time and that's it. No, it's pretty much a mindset that you have to adopt. And so number 3, again, what's the connection? What is the connection? So basically, you start with the end. Then you go to what you have, your tools, which is, again, the same thing as your information. And then your job from there is to build a roadmap to success. That's what this is. Step 1, step 2, step 3. And once you have that plan built out, calculate. So, yes or no, everybody, does that make sense? We're going to put this into action. We're going to practice some problems, but does this make sense? Perfect. And again, we're going to put this into practice, so don't worry if this doesn't make all the sense in the world, because we're going to pair this with the examples to really show you what's up. So here's the great thing. Here's another bonus caveat behind this. And this is why you should really do this. Even if you get stuck, this technique allows you to understand where you got stuck. Because if you're trying to understand what the question is asking you to figure out and you're confused, well, right there, your problem is keywords. Your problem is understanding what the keywords of the question mean. If you're stuck on listing out your information, then your interpretation of the numbers is what's really important there. So for example, you might be looking at a number 30, but if you don't see the word feet next to it, 30 feet or 30 square feet, then you won't have any clue that this is a problem about geometry or a problem about distance, rate, time. That's what that allows you to do. If you want to write anything down from this class today, it's this. It is not about what the numbers are. It's about what the numbers mean. Let's write that down. It's not about what the numbers are. So it's not about what the numbers are. It's about what they mean. All day. It's about what they mean. If there's any advice that I want you to write down today, it's that. It really is that. Because the more you focus on just the numbers, the closer you get to just trying to guess and hope for the best. And I know we've all been there at one point. You don't even need to answer me when I ask that. I know we've all been there. I've been there. Anybody who's ever tried math has been there, because you tend to want to just see what works. But the most effective technique that you can apply is by using reasoning and saying, hey, doesn't matter what the number means, because they could rewrite the problem with a different number every time. But what's not going to change is what's next to the number, the meaning of the number. And so that's what you need to focus on. Focus on the meaning behind these numbers. So with that said, who's ready to try some practice problems out? Who is ready? Who is ready? All right, sounds good. Let's see who learns. Let's see who learned. Everybody, let's start this one out right now. We're going to start off with, again, fundamental, quote, seemingly easier problems, but we will escalate as we go on. So first things first, everybody, what's the first thing we need to do here? Jada has $4,682.60. Is that what you do? Read the question. That's right. Read the question first. Sounds good. Read the question first. So remember, everybody, the question is always going to start with, well, it always ends in a question mark, obviously, but sometimes they give you extra information that you don't need to pay attention to. You always want to start with who, what, when, where, why, how many, which of the following. All of those are action words or question words. You always want to start there. So right here, and we can read this since it's short, but it says, after the check's clear, how much will be left in Jada's checking account? Okay, let's just start there. No context. Don't worry about the numbers. Don't worry about those crazy symbols. I got something in my eye, but don't worry about those crazy symbols. What we want to ask ourselves first is, how much will be left in Jada's checking account? Anybody here recognize any keywords that we might be able to write down here? Any keywords here? I see it there in the chat box. Israel, are you going to say the same thing there? Let's see. What's up, Israel?
Yeah, how much will be like kind of subtraction?
Yes, sir. Exactly. Typically, when we ask, hey, how much of anything is left? Typically, and I am saying typically with a grain of salt, but typically we're saying, okay, if we take something away, what is left? When we subtract, what's the remainder? So we can start here, not by assuming, but by paying attention to the keyword here, left, which means potentially subtract. And then it says in the checking account, how much is left in the checking account? So we got to pay attention to those keywords. So here's what we're going to do next. We're going to go ahead and look at the information that we have to work with to see how we can get there, to see what we can get in terms of what's remaining in the checking account. So I'm going to say equals, and I'll just say that right there. That's what we're looking for. Don't know what it is yet, but that's what we're looking for. Okay, cool. So let's go ahead now and read the story. Everybody pay attention to the strategy I'm about to apply. I am not going to read every single number. Has anybody here ever been stuck on reading numbers or been stuck looking at a fraction just because it looks intimidating? Right, cool. I didn't have to ask that twice. Yeah, of course, of course. If we are intimidated by decimals, fractions, percents, it's going to get us. So instead, skip over it. They're just numbers. They're not going to bite. So Jada has this much money in her checking account. She writes checks for that much money and that much money. After the check's clear, how much does she have left? So here's the opportunity that we have here, everybody. We have the opportunity to tell a story. We're looking for how much money is left in the account. Jada starts with this much, and she wrote checks for this much and that much. Everybody, what does it sound like is happening to that original amount? Whatever that is, the 4,000, whatever. What's happening after she writes those checks? Exactly. The amount of money in her account is going to decrease. The moment those checks clear, boom, boom, you take and deduct that money from the account. So is it fair to say, everybody, step 2 here, the information we have, Jada starts at 4,682 with 62 cents. And then basically the checks, what we're doing is we are subtracting 1,052.50 and subtracting 732 with 99 cents. Is it fair to say that that is what should happen? That is our plan, yes or no? And again, notice what I just did there. I paused and I asked, is this plan appropriate? Is this going to work in terms of the story? A lot of the times, a lot of us just grab these numbers and just, hey, I know how to multiply these numbers, so I'm going to do it. Right? You know, you got to make sure you know that your plan is going to work. So there's 2 ways to get this done. Now that we have a plan that we know will work, let's go through the calculations. And there's 2 ways to go about it. Everybody, who here is thinking of adding the 1,000 and the 700 together and then subtracting it from the 4,000? And who is thinking of subtracting twice? So who wants to add, then subtract? Or who wants to subtract twice? How are you guys feeling about this? Okay. Okay. I see a lot of y'all saying you want to add, then subtract, because you want to get the total amount of those checks and then subtract the whole thing. That's fair. That is absolutely fair. So those are 2 main ways. There are some mental math ways to go, but I'm not going to introduce the mental math until maybe a few more problems into today's class, because I don't want to take away from the word problem aspect of this. So let's go ahead and go that route. Let's add those 2 together and then subtract the whole thing. Let's just do our thing here. So 1,052.50. Let's add that with the 732.99. So if we just go ahead and go down the line without mental math, just going here, 0 plus 9, 5 plus 9 is going to be 14. We have to know these fundamental pieces of addition. Carry that 1. 2 plus 2 is 4. Carry the 1 to 5. Then we have 5 plus 3. That gives us 8. 0 plus 7. And then the 1 right there. So we have ourselves 1,785 and 49. So instead of subtracting both of those consecutively, we can instead go ahead and subtract all at once. And we can subtract right over here. We have 1,785 with 49 cents. So let's go ahead and take care of business here. And let's have ourselves a good day. So with that said, we can't do that. So remember, whenever you can't subtract numbers that we have, we can always go ahead and borrow. So that becomes a 5, and there's a 1. So it's 12. 12 minus 9 gives us that 3. 5 minus 4 gives us that 1. Place that decimal where it was. You got to line things up here. Then we have 2 minus 5. Oh, can't do that. So here's where we'll go ahead, borrow 1 again. So then we'll have 12 minus 5. That's going to give us a 7. Then 7 minus 8. Oh, can't do that. Got to borrow 1 again. If you didn't notice already, I am setting you up for mental math. And so here, 17 minus 8, that's going to give us a 9. Then we have 5 minus 7. Oh, can't do that. Oh, man. Okay. So we'll go ahead and turn that into a 3. Make that 15. 15 minus 7, that's going to give us an 8. And then 3 minus 1 is 2. So with all these rainbow colors here, we're going to have ourselves $2,897.13. So are we good there? That was a lot, right? So $2,897.13. That is choice C. So what did you guys notice about all this when we subtracted everything at once? Who noticed anything particular here? You know, as easy as it was, do you believe that that was quick? Cool. Yeah, like, so a lot of you think it was quick? Oh, I'm gonna show you how we can get quicker. I'm gonna show you how we can get faster. So we'll talk a little bit more about mental math. So keep a lookout for that. But for right now, it's really just a matter of understanding, hey, the process here by which we can go and get this done. So yes or no, everybody, does that make sense? What do we want? What do we have? What's the connection? Yes or no, does that make sense? And if you need to take a screenshot, take it now while my hair is not in the way. There you go. Go ahead. If you want to take a screenshot, feel free to do so there. 3, 2, and 1. So here's what we're going to do. This next question, I'm going to put up a timer here. This timer is not going to be for you to complete the problem. It is simply going to be to snap your attention over to the question and the information and building a plan. I'm not asking you to solve this. I'm going to see if you can figure out what's needed to be done in 45 seconds or less. Because remember, you got 2 minutes on the ASVAB per question for arithmetic reasoning. So what I want you to do is take that first 45 seconds and really push yourself to pick apart the problem and figure out a plan. The actual calculation will be for the remainder of the time. So let me go ahead and get this timer up right over here. And then let me go ahead and bring my timer up there. All right, so there we go. There's a 50-second timer here. Let's try this out. Go ahead. I'll give you 45 seconds to see if you can make a plan nice and easy. Yeah, type ready when you're ready with the plan. Again, don't worry about solving it. You're good. And 3, 2, and 1. Let's go. Let's go. Let's go. How are we feeling? How are we feeling? How are we feeling? All right. So what's your plan? Go ahead. Type that into the chat box, or if you want to raise your hand, go ahead. What's up, Mohammed? I almost said. What's up, Mohammed? How you doing, man? So talk to us. What'd you do first? How'd you determine?
So she got money. So first thing, we need to read the question. So it's how much did Trisha spend? So that means how much come out of her pocket and went to the cashier pocket, the cashier register. So she bought multiple books, and it comes 45, 22 cents, 32, 91 cents, 67, 20 cents, and then 23, 25, 25, 62. So how much she spent? So that means we add all the money together, and that's be the answer.
Exactly. Well said. Simply put, we can follow that plan and we can solve. Appreciate you, Mohammed.
Okay.
So with that said, everybody, I just want you to acknowledge here, like it is very, very, very easy for us to, especially as new ASVAB studiers, going through from the very beginning. Trisha purchased multiple books for her college classes at, then the moment you see, oh, decimal, 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 you might be sitting there thinking, I'm head out. And before you even read the question, you might not give yourself that opportunity. Did anybody here get caught up in just looking at the decimals before you actually knew what to do? I love how all my people in my program are like, nah, I'm good. But some people, it's possible. It is absolutely possible. And so we had to get into the habit again, not worrying about what the numbers are until we know what they mean, until what they provide for us. And so right there, how much did Trisha spend? And we have all these numbers, 45, 22, 32, 91, 67, 20, 23, 25, and 25, 62. So did anybody here try to add these straight up top to bottom? Did anybody here try to do that and torture themselves with that? Because this is where I'm going to show you a little bit of mental math here. This is where I'll absolutely show you a little bit of mental math. So one thing that we can do, this is what I call split and glue. Has anybody seen my YouTube videos or my class videos on my split and glue strategy? Okay, cool. Good majority of you guys have. Good. And if you haven't, don't worry. I got some videos on YouTube for that. I got plenty in the program, but we'll talk about that later. So this is what you can do. Look, basically, we got 4 digits here. Let's go ahead and keep things simple. What I'm going to do is I'm going to split the problem up like this. To be able to calculate faster, because notice I'm not going to add 5 rows of numbers. That's not going to happen. So what we can do is this. This is an easier approach. I'm going to add those right there. Guess what that is? That's 40 plus 30 plus 60 plus 20 plus 20. That's what that is. And once I'm done adding that, then I'll quickly move to the ones, then the cents, and you move forward that way. If you know your mental math and you've practiced enough, you'll understand that this is a much faster strategy than trying to add everything down the line, risking a potential mistake. So here, everybody, do you notice how we can make our lives really easy, really quick by noticing that 60 plus 20 plus 20 is already 100. And then that's going to be 70. And that makes 170 right away. Who noticed that? Who thinks like that when they do math? They don't always go left to right when it's all addition. You can actually pick apart the convenient pieces of it. Well, there you go. Now you do. Because if you would have gone forward, you would have gone 40 plus 30. Yeah, that's 70. Great. 70 plus 60. Don't need to do that. You can look for convenience right there. That's 100. Or you could have said 60 and 40 is 100. Either way would have worked just fine. So I want to make sure you can see that technique there. Then next, I'm going to go ahead and pick apart these numbers over here, the ones. And so I'll just go ahead and say we got 5 plus 2 plus 7 plus 3 plus 5. And guess what I noticed here, everybody? The moment I write that down, man, I got me 10 right there. And I also got me 10 right here. And then I got myself a little lonesome 2. Guys, what's 2 plus 10 plus 10? That's 22, right? That's 22. So I got myself a 22 there. Nice and easy. And then you just go and continue and pick this apart. That's really how I suggest doing this. Again, there's a million different ways to do this, a million different ways. I just want to present to you a slightly faster way than literally going down the road, down the road, down the road, down the road. Trust me, better ways to do it. So, Samuel, congrats on passing, man. Let's go. Text me. You know I'm going to want your review. Text me, man. Congrats. What'd you get? I love those surprises, man. I love them. Let's go. And so we'll go down the road right over here, man. Ooh, Samuel, man, text me. You better text me. I'll find you. So here, we got 20 cents. Now I'm distracted. 90 cents, 20 cents, 20 cents. And we have 60 cents. And so with that, anybody notice anything convenient here? What do we notice that's convenient here? Yeah, exactly. The 60 cents, 20 cents, and 20 cents. Those are convenient right there. Boom. What does that make, everybody? 60 cents, 20 cents, and 20 cents. That makes what? $1. That makes a whole dollar. So we have a whole dollar right there. And then 90 cents plus 20 cents, that's $1.10. Because think about it. 90 cents plus 10 cents is $1. Another 10 cents is $1.10. Just write that in order so I don't confuse anybody. So added together, that's going to be $2.10. So we've got that there. So right now we're looking pretty good. So now all we have to do is add up this last row here, nice and quick, and we are set because we can add it all together and we're good. Now it looks like it's taking a while, but that's because I've been slowing down to show you everything mentally. When you actually get into it, much faster. So we're going to have 2 cents, 1 cent, 0 cents, 5 cents, and 2 cents. So from there, that's really just going to be 10 cents. That's 10 cents because you have 5, 7, 9, and 10 cents. So this all together becomes 10 cents. And that's it. All you have to do is add everything up together and it'll work itself out. So really what this turns into in your head is going to be 170 plus 22 plus $2.10. And I'm going to zoom in a second. I got y'all. I'm going to zoom in a second here. Let me move this on over here. And again, the point is that this is happening in your head. So this will not take up this much time and it won't take up this much space on your paper. Does everybody here notice how convenient adding this on paper is? Does everybody notice how convenient that is compared to this? Like just compare it side to side. Just compare it. That's much more convenient because you go down the line. That's going to be a 0, a 2. 2 plus 2 is 4, 9, and 1. 194.20 is your answer, and you're good. And you're good. And so all we did here, Krishan, all we did here was just add everything up. That's all we did. That is all we did, Krishan. I got to make sure you understand that, man. Remember, the idea is what was coming first. The idea is what's coming first. We've got ourselves 194.20. That's going to be B. So even when you know what to do quickly, if you have a lot of work to do mathematically, you better be sure that you're confident and you know how to do it quickly. There's a balance here that we have to hit between, again, recognizing what to do and being able to do it very, very quickly. Johnson, that's what's up, because you've been learning that mental math. I love seeing that. That was a private message there. But yeah. Yeah, so one thing I would also do, so in my head, if we're talking like real talk, what I would do in my head, if I'm doing this live, I'm going like this. Okay, 40, 70, 100, 170, 175, 177, 184, 187, 192. From 192, I'm going forward here, and I'm going to look at this and I'm going to say, okay, that's definitely going to be more than 192. So I'm eliminating A. So, okay, cool. So we're going to go ahead and keep going here. Add the 2. So it's, add 1 with 10 cents. Add that, add that, add that. Bam, 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 bam. And that's how I would technically do it. That would take me about 15, 20 seconds without any pen or paper. And it's okay, yeah. If you're saying that you're slow, are you saying that you're slow now or you're going to be slow forever? Question. That's a real question. Anybody here feel like they're slow at mental math right now? Anybody here feel like they're slow at mental math now? Now, okay, cool. Look at a lot of people saying yes. Are you going to be slow at mental math forever? That's the real question. Like, do you believe in your ability to grow with practice? Because at some point in your life, hey, guess what? You can tie your shoes at one point in your life. But now you can probably tie your shoes and hold a full conversation with somebody. That's fair to say. So you can't let I'm not good at math now affect your ability to get better at math later. Like that's really the big disconnect that a lot of people have, is seeing where they are now and not being able to see where they can be. It takes practice, guys. You can't forego that practice because that's how you get better. So with that said, let's go ahead and keep getting serious here. Let's look at the next one here. Now we're gonna get a little tougher now. We're gonna get a little tougher, so pay attention now. The story is the most important thing. Let's go. So everybody, let's try this out. Hey, Fernando, I'm glad you're here, man. Let's go. So let's start here, everybody. What's the first thing we need to do? What's the first thing we need to do? Let's take it nice and slow. Read the question. So right over here. How many candy bars did she buy? Sounds good. So I'm just going to write down, first step, the question. She bought blank candy bars. Sounds good. So there's a way to do this with an equation, but I'm not going to go that route. I'm going to do this by just using the story to our advantage. That's the big thing here. Yeah, for sure, Simone. Yeah, you can absolutely use an equation here, but I'm going to do this with the story instead to show you how you can use the story to your advantage. So let's read through, everybody. Ming spent $19. I don't care about that number. Ming spent this much money on a magazine and some candy bars. if the magazine cost that much and each candy bar cost that much, then how many candy bars did she buy? Okay, so let's go ahead and write down the ideas here. Right on, Felix. I like that you used mental math there. I just did this one in the math study guide. Juanch, or Carlos, my bad. Let's go ahead and try this one out here. So 2, what information do we have? We have this much money spent on the magazine and some candy bars. Key words there, key words. So here, $19. That was spent on, again, the magazine and the candy bars. Okay, so let's go ahead and try this out now then. Hey, what's up, Abraham? Go ahead in the chat box there. So then from there, it said the magazine, that was $2.60. And then each bar was $2 or $4.20. So right over here. Let's just write the information down. Just write the information down first. Okay, so with that said, man, Abraham just passed again. Oh, God, man, do that in the beginning of class, but I love seeing it, man. I got to congratulate you. Abraham, congratulations as well, man. Text me on the side, but got some folks calling me as well here. But congratulations, Abraham. But text me, man. Stick to the class if you could. I'm proud of you, for real. But I can't take too much time congratulating you, man. I wish this was the beginning of class. So back on topic here, everybody. Dang, man, Abraham, love you, man. Back on topic here. So first off, let's make sure that we understand what's going on. Because if we don't know what the question's asking us, then we probably might be confused right now. So quick questions, everybody. Number 1, yes or no, are we looking for the number of candy bars? We're looking for the number of candy bars. Good, good. Number 2, let's talk about what these numbers that we see here, what do they represent? Let's talk about this. Everybody in the chat box, tell me, what does the $2.60 represent? Write that down in the chat box. What does the $2.60 represent? I want to see how quick we can be there in the chat box. The magazine, okay. How many magazines? How many magazines? Okay, cool. Again, this is me testing to see if you understand context here. Again, it's about what the numbers mean. It's not about what they are. So let's talk about the $19.40. What does that represent? What is that about? The total for what? The total for what? Okay, so I'm agreeing with those of us, the majority of us are saying the magazine and the candy. Now, question, is the $19.40, is that for the magazine and one candy bar, right? It's one candy bar, one magazine? Okay, cool. I didn't get y'all. Good, good, good. I love that y'all are paying attention. Yes, Ming bought some candy bars. We don't know what that number is, but we do know that potentially it's more than one, because we see here that each magazine is $2.60. We see that right here, spent on a magazine, some candy bars. Now, some can be one, but we can assume that it's more than one in this context. Now, let's talk about a plan here. Great job, guys. Great job. Let's talk about a plan. Everybody, true or false, if we are trying to find the number of candy bars that we bought, and we know how much each candy bar costs, then shouldn't we be using the number or the money amount for just the candy bars, only what we spent on the candy bars? So without the magazines, should we be looking at the cost without the magazines? Yeah, we should. We absolutely should. And here's the reason why. If you're looking at this question and you're thinking, oh, the word each means that we should be multiplying or dividing, which in this case means we should be dividing. Well, what happens if you divide the 1940 by 420? That wouldn't work because this includes the candy and the magazine still. So everybody, do we see how we need to take out the magazine so that way we're just left with the candy bars? We need to take that out. We have got to take it out. And the one way we can take it out is by subtracting it, $2.60. So that's step one. Take out the magazine cost because I only want the cost of the candy bars. If I have the cost of the candy bars, then what I'll be able to do is see how many times $4.20 fits into whatever that number is. And question everybody, if I'm asking how many times a number here fits into another number, what am I asking to do? That's right, Simone, Akwesi, Muhammad, David, we're dividing in that case. So the plan is going to be take out the magazine, then divide by the cost of each candy bar so we can find how many candy bars fit in that dollar amount. That's what we want to find. So let's take it nice and slow here. Let's see what we can do. If we're subtracting $2.60 here, let's get to it. 0 minus 0. Okay. Then 4 minus 6, can't exactly do that. So we can go ahead and make that an 8. Boom. 14 minus 6, everybody hit me. If I'm out of, well, there you go. First one there. Boom. That's an 8. Let me just keep using black to be consistent. Then 8 minus 2, that gives us 6, and then 1. So let's be sure that we know what we're doing here. Everybody, the $16.80, what does that represent? What does that represent? The money spent for the candy, exactly. That's the total cost of the candy bars. Because again, we took away the magazine. And so now this is only candy bars left. Yes or no, do we see that? Yes or no, do we see that? That here, this $16.80, that is now the cost of just the candy by itself. We have taken away all that money for the magazine. It's okay, Tony. Thanks for coming in. Cool. So then from there, what we'll do here, if it is $4.20 for each candy bar, each candy bar, we're going to divide that $4.20 into the $16.80. We'll divide it in. Exactly, Akwesi. Now we'll divide it. Key, I'm glad you figured it out. Exactly. So here, we'll go ahead and take the $16.80 and we'll divide that by the $4.20. That's how we can get that done. And boom, because again, we'll see how many candy bars fit. How many candy bars fit into the 1680. That's what we're doing here. That's the reasoning behind that. We're dividing because we're seeing how many times we can put $4.20 in there. And so we do our work. The answer will be 4. One way you can see that is by saying, hey, 4 times 4 is 16. 2 times 4 is 8. Did anybody look at it that way when they try to divide? You can see like, oh, 4 times 4 is 16, 2 times 4 is 8. So that could give us the answer there. And if you didn't see it that way, no worries. No worries at all. Another way you can handle it, you could try different numbers out. Try 2, try 3, try 4. You got the answer choices right there. You could try that out. Another way is by using a little bit of trickery here. You could go ahead and move this over here and that over there to make it 168 divided by 42. That's another way you could try it out. Again, whatever you do to one side, do to the other. Whatever you do to the top, you do to the bottom. Just different ways that you can think about it. But at the end of the day, the best way, if you are not familiar with dividing by big numbers, simply going to be use those answer choices. multiply by 2 times 3 times 4, and you'll figure something out. But besides the actual calculation, yes or no, does the idea here make sense? We had the total amount with the magazine included, but we only wanted candy bars, so we took that out. Then with what was left, we went ahead and did a little bit of division. Now, how hard those calculations were, again, depends on the numbers, but the ideas should really be sincere. So that's what we really want to focus on. It's always going to be about, again, what ideas make sense here. And then we get into the calculation. So with that said, no worries if we are lost. So Krishan and Yamari, so let's ask ourselves, at what point, this is the first problem we did. You just switched the problem. I'm not saying anything, Carrie Ann. So again, here's what we got going on, everybody. Step one, you ask yourself, what are we being asked? What's the question? The question was, how many candy bars? Step two, what information we have? Well, we have the total with the magazine included. Take that magazine out. We only have candy bars left. Divide to get the number. And we can go that route. Now we're going to present ourselves with a different problem here. And again, I'm going to give you just about a minute to see if we can go ahead and figure out a plan. I'm going to give you a minute here. I am very slick. So with that said, 3, let me get this timer up. We're going to try this next one out. And then after this one, I believe we are getting into timed practice. Yep, we are. So 3, I'll give you about a minute here. Cool. So let me give you that time to get a plan in. There we go. Again, I'm going to give you a minute here to come up with a plan. The best thing you can do, ignore those numbers. It's about what the numbers mean. Let's go. Yeah, the answer was 4 to the previous question. And Junie, yes, that is exact. That's perfectly stated. Now some good mental math there. I love seeing it. Yeah, the answer was 4, everybody. Yep, it was 4. And Krishan, for sure, I got you. So this is another different type of problem. So we have 10 seconds here. Do your thing. And 1. All right, so go ahead, try typing out those plans in the chat box. Try typing out those plans. And one thing I really hope that you guys are appreciating here is that I'm not, so there's one thing that I hate that some teachers do sometimes. And you know, there are times where it's appropriate, but when it comes to word problems, it is irresponsible of me to literally feed you the same type of question back to back to back to back to back. If I were to do that, I'm not preparing you to think critically. I'm not preparing you to think about every problem as if it's a brand new problem. Notice how we just got done with over here. Krishan, get ready to take your picture. We just got done with 1, 2. Krishan, take your photo. 3, 2, 1, 3, 2, 1, 3, 2, 1, 3, 2, 1, 3, 2, 1. There you go. So we have another question here that was different from the first one. And this third question was more different than the previous 2. And now we're looking at another question that's even different. I'm not saying it's harder. I'm just saying it's different. And so what I want to make sure you guys understand is this. Treat every word problem as if it's a new problem. Stop trying to memorize the previous question and try to use that same exact strategy for the next one. So yes or no, has anybody ever seen practice questions on the real test or practice test where they're talking about the same things, whether it's money or purchases or whatever it may be, but there are 2 completely different problems in terms of how you solve them. Have you guys ever tried that or seen that? So if you've never taken the ASVAB so far or have never taken it before, pay attention. You do not want to get roped into that trap, hoping and wishing that what you did in the last problem is the exact same way that you'll solve the next one. That is the easiest way to fail. You have to be able to see every problem as if it's a new one. And that's why we start with the question. So let's go here. Thank you, May. I appreciate that. So right here, how much does she earn if she worked 5 regular work days and 7.5 overtime hours? So here we go. The first thing I noticed was the word and. That's the first thing I noticed. And the word and separates two key things. Let me just erase this here. The word and separates two key things. So we're looking at, again, how much does she earn? But then right here it says 5 regular work days, and over here 7.5 overtime hours. So everybody, I think this is pretty relatable, right? I think this is a pretty relatable problem. Is it fair to say, everybody, that what we're looking for is basically this? Find this. Find the pay for 5 days and then add that with the pay for 7.5 overtime hours. Is that fair to say? If you were to look at that, I haven't even read the question or the full problem yet, but I think we can all agree that if we read the question, we need to find whatever the cost is or the pay is for 5 regular work days and also for 7.5 overtime hours. If we can find those two things, all we need to do is add them together. So one more time, yes or no, do we agree with that initial plan? And it's okay if you didn't notice that before. It's totally okay, Krishan, totally okay. Because what I'm training you on is, again, picking up on those keywords in the question statement. We cannot start going, if Samira earns $33 per hour during a regular workday of 8 hours and $35 an hour for any work she does after 5 p.m., what? And plus, there's a grammatical error here. That should not say if. Let me go ahead and take that out of the way here. That should not say if. That should just say Samir. So with that, obviously I'm human, right? But taking that away, yeah, like that can get real confusing real quick, especially if you don't know the purpose of that. But here's the great thing. I can now identify this with color coding, $33 per hour during a regular workday of 8 hours. We can write that right here. 33 per hour, 8-hour days. And everybody, how many days? How many days are we looking at? 5 days. So basically, and then, we're going to take down this information over here as well. 35 per hour and a work after 5 p.m. So the overtime pay is 35 per hour. So let me ask y'all a sincere question. How do we find how much Samira makes in 1 day? Because to get to 5 days, we need to find out how much she makes in 1 day. So how are we supposed to find how much Samira makes in 1 day? Right, we multiply. Exactly, we multiply. So everybody, is it fair to say that if I'm looking for 1 day, that's going to equal $33 per hour times 8 hours? Let me just not say 8 or hours there, but that'll be for 1 day. So if we do the math there, 3 times 8, that's going to give us 24. Then from there, 3 times 8, that'll give us 24 again. Add the 2, that'll give us 26. So this is for 1 day again. For 1 day, it's fair that that'll be $264. All right. So question, everybody. Is that it right there? Is that all the money she makes for 5 days of work? I would vomit if that's what I made for 5 days of work. But no, it's not. We're not done yet. What must we do here? What must we do? Again, it's about the reasoning, everybody. It's about the reasoning. What's the reasoning here? We need to multiply by 5, but why? Give me a reason why. Yeah, because it's 5 days. And so I'm going to circle back, and because I love how someone addressed it, there is a faster way to do this, but I'll address it in a moment here. So times 5 days. We need to multiply by 5. So that way we can get the full 5 days. And so here we go. Let me move this over just a little bit here. Bam. So we can do 4 times 5, that's 20. 6 times 5 is 30. Add the 2, 32. And then 2 times the 5 gives us 10. 10 plus 3 is 13. That's more like it. That seems like a job that I would want to be at for 5 days of work. Sounds good. Cool. So boom, right there, 1320. So 1,320. Everybody, what does that represent again? What does this represent again? Let's be honest again. That's 5 days of work. So are we done on this end, everybody? Are we done on this end? On this end. So for the 5 days of work, are we done figuring that out? Yeah, now we got to do the overtime. Yeah, now we got to do the overtime. But real quick thing here, everybody. This is a really cool thing I want to point out. I'm not sure who said it. I saw it in passing because I was waiting on someone to say it here. So anybody here notice that we got to do 33 times 8 times 5? Did anybody here notice that we can actually turn that into 33 times 40? It's the same thing. It's the same thing. We would have gotten the 1,320 just the same. Just the same. We could have gotten it just the same because all you got to do is really ignore the 0 and then bring it back at the end. And that would have been a little faster. That would have been a little faster. So remember, everybody, mental math is not always to give you the whole Hail Mary, like leap of faith. Sometimes it's really just noticing some small conveniences that you can apply to give yourself an easier time. Yeah, it's all about saving time. Whether it's saving 5 seconds or saving 50 seconds, mental math, the more you apply it, the more time you save. And so you could have noticed that, hey, I'm going to be doing 33 times 8, then times 5. 8 times 5 is 40. So I could just do that faster, right? Could just do that faster. So with that said, let me just go circle back now. Let's go ahead and figure out what the overtime pay is. Is this a little easier, everybody, with the overtime pay? What do we do here? What do we do here? I see Junie going like, oh yeah, that's easy. Yeah, oh yeah, that one's easy. Yep, we're just gonna go ahead and take that 35, multiply it by 7.5, and we'll have ourselves a good day for sure. We're good. So we'll take that right there. 35 times 7.5. And let's go. Nice and easy. Here we go. So we'll take care of 5 times 5. That's going to give us 25. And then we have ourselves that 3 times 5. That's going to give us 15. 15 plus the 2. That's going to give us that 17. So then next, what must I always remember to do on the next line when I'm multiplying, everybody? What must I always do? Appreciate you, David. That's right. Tack on that 0 right there. Let's keep the math going. So now we're going to take care of business here. 5 times 7. That's going to be that 35. I'll erase that right there. And then here, 3 times 7, that gives us 21. Add the 3, gives us 24. Before I even add these, what must I do at the end? There's always something you got to recognize with decimals and multiplication. What do we have to do at the end? What do we do? What do we do? You got to make sure you fire that off in your head always so you don't forget it. Very easy to forget. That's right. Move that decimal back. Exactly. Bring it back. Bring it back. That's right. So we're going to add everything back. 5. And if you want to, this is one thing that I've been taught that could prove convenient. You can just put the decimals like right there immediately, or you can just wait till the end. It's really up to you. But here, 7 plus 5 is 12. 1 plus 4 is 5. Carry the 1 as a 6. Then you bring that 2 right there. So again, we have that decimal place right here. And you bring it back right there. Boom. And so there we go. So where's the 35 coming from? I got you. That's $35 for the overtime. So 7.5 hours with 35 an hour. Good question. So just making sure that you saw that. And so boom. So what is this 262.50 or 262.50? What does that represent? Yeah, that's overtime pay. Yeah, that's the OT. Yes, yes, yes. So what did we say we needed to do once we figured out the 5 days and then the overtime? What did we say we needed to do? That's right. We got to add them together now. We're going to add it together. That's exactly what we said we would do right here. That's exactly what we said we would do. Find the pay for the 5 days, find the overtime, add it together. Notice how this problem was very easy to figure out a plan, but the calculation, geez, right? There's a lot. And so that's why we have to be prepared to be able to calculate quickly, guys. This is why it's so important. So let's go ahead and add it together. Let's have ourselves a good day. We've got ourselves 1,320. And we're going to add $262.50. So if we do that right there, boom, we'll get to it here. 0, 5, 2, 8, 5, 1. So $1,582.50. Boom. That would be answer choice C. Right there. So I'm going to scroll down just a little bit here to give you guys the opportunity to screenshot. There we go. Give you guys the opportunity there to screenshot. I don't know where my funny glasses are. It's a shame. I got my cool glasses right there, but I will wait. I'll do the next screenshot. It's all good. So with that, you guys know I love doing my funny glasses there. So we got some questions here. Alec first, and then Sesh. Go ahead, Alec. What's your question, boss? Let me know.
Hey, so.
Oh, you turned off your mic. Go ahead again.
I was confused myself with the first ending of the question when it says if she worked 5 regular work days and 7.5 overtime hours. I wrote out that 35 was the overtime pay after 5 p.m. and I put 35 times 7.5, but at first after that, before you started explaining, I 7.5, and I said, what if the 5 days times 7.5 of the overtime times it by the days, because you're already doing the 5 days plus the 8 hours of days, which gave you 40 hours. But what about the 7.5 times by how many days, and then times it by 35 hours of that extra overtime? That's what, how do you know the difference between those two? Just the time 35 with the 7.5 versus the 7.5 with the 5 days.
Gotcha. So great question, by the way, Alec. So for those of you that didn't catch that, what Alec is asking is essentially this. And Alec, you tell me if this sounds in the ballpark. Alec, what you're asking is, how can we determine confidently that these numbers are associated together and those numbers are associated together? Like, how do we know that they're not being mixed in whatever form? Is that fair to say?
Yeah.
So, Alec, great question. And so this is what it boils down to when it comes to being able to recognize the story of the problem, breaking down the story. So here, another thing that may have confused people is this: work days, overtime hours. That may have confused some folks as well. But here's the thing. What we need to understand is this: 33 an hour is associated with a regular workday. And a regular workday is 8 hours. And then here in green, I highlighted it here, 35 an hour for any work done after 5 p.m. This is where it's implied that we're talking overtime here. So overtime meaning not a regular workday, beyond the regular work hours is overtime. So that's how we can tell that the 35 per hour is associated with the overtime hours. Remember, it's not about what the numbers are, it's about what they mean. So let me go ahead and highlight this one more time here with another color. I'll use red. So 35 an hour after 5 p.m. So again, which is not regular, And we can safely assume that overtime hours is what we mean by after 5 p.m. So great question, but that's how we can associate the 7.5 and the 35 together. Then on the
So don't
flip
worry
side,
about the days.
what's up?
Don't worry about the days if it says hour, because it's not talking about a work day with the overtime.
Yeah, and so cool. So to address that here, what you want to do here to get for 1 day, we know that 1 day is 8 hours. So if you want to figure out what one workday, for the amount of one workday, well, let me go ahead and just work backwards here. If you want 5 regular workdays, you got to figure out 1 regular workday first. Once you figure that out, then multiply by 5. But to figure out 1 regular workday, we see that 1 regular workday is 8 hours. And notice how it says 33 per hour, not per day, per hour.
Mm-hmm.
So that's how we have to discern the information there and say, okay, 33 per hour and 8 hours in a workday, 33 per hour, multiply those together. You get 1 workday. From there, multiply by 5 to get 5 workdays. Let me know if that makes a little more sense there.
So the overtime will be already given.
Yeah, the overtime was given to us. This is how many hours of overtime, and this is the money per hour of overtime. So that's how you know you can associate those together.
What if they have a problem where they'd be like, okay, how many hours of work time if there were 7 point of overtime hours, and we give you 35 out, we give you $35
You
an
said
hour.
how many hours of overtime if it's 7.5 hours of overtime? You already said it. So you answered your own question right there. Now, of course, the questions can be framed in different ways to find different numbers. And so the moment that you find a question where that's even the potential there, shoot it over to me. I'll show you exactly how to do it.
Oh my God. I just done confused myself. Sorry.
It's all good. It happens, man. It happens. It's all good. It's all good.
7.5 overtime hours. Now, what it say? Okay.
Yeah,
35.
so I don't want to, sorry to cut you off there. I don't want to speak in hypotheticals because we do need to move forward in the class. But again, if you do find a question similar to that, man, shoot it over. I got you. I can even create some too for the next class. But I want to get over to Sesh and Yamari because they were waiting for a minute. And then we will be moving forward right after that. Dwight, if you still have a question, hold on to it, okay? So go ahead, Sesh, with that question there. I just muted you by accident. Go ahead again. There you go.
You kind of answered the question for me.
It's all good. It's all good.
I'll let a female answer the question next. That's what I was trying to say.
No worries. So go ahead, Yamari, go ahead. And then we're moving forward to this time practice.
Yes, question on the mental math. See, I see when you divide or subtract, you start from the right side, correct? And if you have a big number, like say, like if you have a big number and I see you add that number, say if you say like the answer is 12, you will add that 1 to the next number, and that number, like that 1 adds to it. Like, how does that work? Like, which number, how do I know which number I am adding?
Yeah, so that's not really mental math. That's just the regular setup for addition and subtraction. And so if you want to go ahead and get that practice, shoot me a text right now. Just say, hey, coach, you told me that you would give me some extra videos for addition and subtraction for the fundamentals. And I got you.
Okay. I appreciate it.
Yeah, because you're in the program, man. I got you. So Carlos says you can't hear, so change your audio output settings, the microphone icon. Okay, so with that said, everybody, so far, do you feel like you're gaining even a bit of confidence as we've gone along here with those 4 different types of problems? Like all 4 of those problems, massively different. But are you feeling like you're better trained here in terms of seeing what can be done regardless of what the problem is? Are we feeling pretty good on that? Tatiana, I saw your question. Shoot me a text. I can create more for you. I got you. Okay, so Dion, I see that you're having a little struggle there. I see some folks saying yes, a little bit. I see a lot of yeses, which is cool. Feeling better every video here? Not yet, Yamari. Kind of with Dwight. Okay, cool. Thanks for being honest. This is what we need, right? We need this to grow. So remember, it falls down to this. Stop worrying about the numbers. Worry about what the numbers mean. The meaning comes first. The meaning comes first. I'm telling you guys, the word problems are not going to just magically make sense every single time. We have got to stop focusing on the numbers. It's the words. So again, step number one, what is it that we want? Step number two, what is it that we have? And step three, what can we do with what we want and what we have every time? And for sure, I get it, Emily. Yeah, right. It's gonna be confusing at first, especially if we're not used to seeing it this way. But we have to really trust the process here and give it time to develop. So we're gonna get into some more word problems here. That's all good. Hey, no, tomorrow, good luck. But what we're gonna do here is this. Before we continue, I do want to make sure that we get to that shirt raffle because we are way past halfway done the class. I will announce a winner at the end of class, but everybody go ahead. If you want to go ahead and enter yourself to win a free hoodie or a free ASVAB ASVAB shirt, go ahead, text shirt raffle to that number right there, 833-321-0182. Go ahead and text that over. We will pick a winner at the end of class, and you got to stay to the end to know that you won. If you leave, I will give it to the next person or the one after. So go ahead, type that in there, shirt raffle, 833-321-0182. And our sponsors over at Chipotle will be right back. So go ahead, take a few moments there. Let me let Alec back in there. 833-321-0182. So 833-321-0182. Text shirt raffle, all one word. One word, one word, one word. And this is where my phone is blowing up again. Cool, great, sweet. Jeez, it's just like last week. So there it is. Shirt, phone's blowing up. Yep. You guys are awesome. So I'm going to let that go for 4 more seconds. 3, 2, 1, and good. Hey, Krishan, don't worry. You're in the program, right? So you're going to get the recording first thing tomorrow morning. You're good. You're good. All right, so here we go, guys. We're going to practice with the timer again. Practice with that timer. Let me go ahead and get that up here. So this time what I'm going to do is I'm going to give you now a full 2 minutes and 15 seconds here. A full 2 minutes and 15 seconds to go ahead and really develop a plan to the problem that we're doing. Okay? That's what we're going to do now. I'm going to give you the full 2 minutes and 15 seconds. Now, I am not expecting you to fully solve the problem. I am expecting you to figure out what is it that you want to find out, what information you have clearly listed on your sheet of paper, and that's it. And then try to build a connection, make a plan of some sort. If you're able to actually do the math, great, but that's not what I care about right now. What I care about are steps 1 and 2 and 3. Can you identify what is it that the question's asking you for? Can you identify the information that you're given? Not just the numbers, not just the 70 cents or $2, but what those mean. Seriously, guys, stop looking at the numbers and pay attention to what they mean. And 3, do you know what the information that you have is? Do you know how that's connected to what you want? How can you get there? Then if you can calculate, great, 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 great. But what I care about is the plan. Go. For everybody here, yes or no, were you able to determine what the question is asking? Yes or no? Were you able to identify the question? Were you able to identify the question? How much money would you save per pair if you used the coupon? Okay, so a lot of us were able to identify the question, but my follow-up is, do you understand what the question is asking you to do? That's the better question, right? Do you understand what the question was asking you to do? Because this is one of those questions where the math is given to you in the question. But again, it takes that experience. It takes that understanding of these key words, because the biggest key word is what in that question statement, everybody? Besides how much money? What is one key word here? Save. Exactly. Saving meaning the difference. And there's one other word here, save, and then the follow-up word is what? Per pair. Per pair. Everybody, is it fair to say that if we're asking, so again, it says how much money, and then it says save, well, how much money, and then save per pair. Is it safe to say that we're looking at the difference in the price of one pair for that price and this pair at that price? Is it fair to say that we're looking at the difference in the price for one pair of each deal? So this is where we have to, again, take the time to understand what the question's asking. Let me write this down for us. So if we're looking at this and it says, again, how much money would you save per pair? Well, if you look at the question, it says you can buy this many pairs at this deal or this many pairs at that deal. Okay, so it sounds like I'm going to go and do this. For the first deal, minus this much money for the second deal. But here's the key thing. Everybody, the key phrase per pair means how many pairs? Per pair means how many pairs? Just one. Exactly. The per pair means one pair. That's really where we have to, again, take our time and let it develop. This is not an easy topic today, guys. Not an easy topic. But if you're starting to pick things up here, there's a lot of hope for you. Even the little things, even the smallest things, even when I'm explaining it and you were stuck before, there is hope if you're picking some of this up. So again, per pair. So one pair here and one pair there. We need the price of one pair in each. Here's what we're going to do, everybody. Let's go ahead and get to some action. We see here two pairs at $1.40. Let me go ahead and write that down, everybody. So here, two pairs for $1.40. Everybody, just go. Thank you. Hey, right on, Jalen. I'm glad it's making sense, man. So everybody, let me just ask this pretty rhetorical but very sincere question. If you know that two of anything costs this much money, how are you going to figure out how just one of them costs? If you know that two of them cost this much, how are you going to figure out how much it is for one? So look at those natural answers. These are natural answers right here in the chat box. If you're on your laptop, you'll see me pointing to the chat box. If you're on an iPad or phone, you won't see that. But this is where the chat box is for me. And notice how every person that's replying right now is saying divide. Naturally, right? If we know that two of these things is $1.40, to get one of them, divided by two, divided by the number that you have. This is where, again, your intuition really needs to kick in. You got to let it develop. You got to let your mind naturally answer, because a lot of the times your mind knows what's up, but we're so tense because we're dealing with decimals and we're dealing with this that we may not allow ourselves to see it. Did that happen for anybody in this problem? Where after I explained it, you're sitting here like, oh, okay. So again, this is where that practice needs to meet the strategy. Because if you just know strategy without practice, you're still going to tense up. But with more practice, we'll be able to relax and let it develop. So here we go. It's all good, Johnny. Things happen. So we're going to do 2 going into $1.40. So of course, 2 does not go into 1. But 2 does go into 14. Everybody, how many times does 2 go into 14? That's going to be 7. And that's going to be 0. So everybody, what does the 0.70, what does that represent? Exactly. That's for the price for one pair. That's the price for one pair. And we'll put that right here. That's 70 cents for one pair. So everybody, if to find the price of one pair there, we have to divide the money by the number of pairs to find one pair, is it fair to say that we have to do the same thing on the other side? Take the total amount of money, divide it by the number of pairs, and we'll then find the cost per pair. Yeah, it's very fair to say. And again, we have to think about it naturally, because with word problems, a lot of the times, thinking of it naturally definitely does help out. I can bet you right now, if you're looking at a 20-question AR test, I want to say at least 7 or 8 of those problems, at the very least, can be solved with intuition. So here, on the other situation, we had, let me use a different color here. Let's use blue. 25 pairs, $10. So right over here, 25 pairs for $10. Okay. So what we need to do here is divide $10 by 25 pairs. And if you're confused and you're saying, well, shouldn't it be 25 divided by 10? Why 10 divided by 25? Think about it like this. In the previous problem, we had $1.40 and 2 pairs. Divide by 2 pairs to get 1 pair. Here, we have $10. Divide by 25 pairs to get 1. Because the $10 is 25 pairs. So divide that by 25 to get 1. So that's how you can confirm to yourself and not get confused in terms of, should I do this one way or the other way? Again, think about it naturally. Let it lead the way. 25 divided into 10. And I know that 25 doesn't go into 10, so I'm going to put those decimals right away. So then, with that said, everybody, 25 doesn't go into 1. It doesn't go into 10. How many times does 25 go into 100? 4 times. So we got ourselves a 0 there, but we have a 4 right here. 25 times 4 is 100. Got ourselves a 0. Carry that 0 down, boom. And we got 0.40. Everybody, what does the 0.40 represent? Exactly, 40 cents per pair, right over there. And so what did we say we would do? We said that once we found out the price per pair for that one deal, then the price per pair for the second deal, right over here. Once we found that out, then we would subtract and we would find the difference in terms of how much we are saving. So everybody, right here, 70 cents minus 40 cents is 30 cents. And what does the 30 cents represent, everybody? What does the 30 cents represent? That's right. Save money, live better, eat a pear. Sounds good. Boom. Savings per pair. And we are good. And so if you're looking at that and you said, hey, I took a guess and I got it right, I'm awesome. Well, guess what? Sure, cool. But if you guess while you practice and you get it right, that doesn't mean anything. If you guess on the ASVAB and you get it right, great job. But when you're practicing, do not ever settle for taking guesses when you practice. So big piece of advice here, everybody. When you are practicing, do not settle for guessing. When you are practicing, you need and you must understand the why. You must understand the why. So with that said here, if you have questions, go ahead and raise your hand here. So Iwe, why are we minusing when we are working only with coupon purchase? It's because here, great Iwe here. How much money would you save per pair? So if I tell you this, think about a different question. If I say, yo, I'm going to go ahead and go to Chipotle on Monday, and I'm going to buy my Chipotle burrito bowl for $8. But if I go on Tuesday, I could buy a burrito bowl for $5. How much money would I save if I go on Tuesday? Oh, it would have been $8. Take away the $5. That's $3 difference. That's $3 of savings. So does that make sense with this analogy here? If we're talking about the pairs, if I found out how much one pair costs at that price, the other pair at this price, if I subtract, I'll see how much I'm saving. Same idea. Hell yeah, Chipotle math. You know how I do things. So with that, let me go ahead and get Dwight there. What's going on, Dwight? What is your question, man? I got you.
You can hear me now, coach?
Yeah, what's up, Dwight?
Yeah, good evening, coach. I want to ask you one question, but it though tell me if it's a dumb question, right? Split and glue, you do it with all of the maths question them.
You can, yes.
So you always have to add a number to split and glue, right? You add a number, always add a number to it, right? Yes or no? Wrong or
Depends on the
right?
operation. Yeah, split and glue applies to every operation. It applies slightly, it looks slightly different, but it's the same idea. So which operation are you talking about? Addition, subtraction, multiplication, or division?
Like any maths question, certain of the maths question we got to do with split and glue, right? Certain of them are just like it
You can do split and
depends.
glue in any calculation. Any calculation.
Any calculation. So if you see 70, if you see 70 or you see 2, you add a 0 to it, right? That's what you did in the first. You were showing something about split and glue. I think it was the second a question you were showing since night. You were showing about the split and glue. I doesn't know I can't remember which question was.
I got you. So what I want you to do then is so the recording's gonna be out first thing tomorrow morning. Take a picture of it and then screenshot it with your phone and send it over to me. And I'll show you exactly, because you have iPhone. So I'll send you a voice message showing you exactly how the split and glue would work with that problem. I'll show you exactly how. I just can't go back all the way right now because it's already really late in the class. But if you can go back to the recording for tomorrow morning, screenshot it, send it to me. I'll tell you exactly how to do it.
All right. Thank you, sir.
Yeah, I got you. So would you be able to do 10 divided by 25 as a split and glue? Yeah. So you have to realize that there is a decimal place there that you can move over with. And so instead of thinking about it as 10 divided by 25, you can think of it as 100 divided by 25, but move a decimal back. So that'd be 4.4 with the decimal coming back. So there's the answer to that one. Kevin, go ahead, my man. What's up, Kevin?
All right, sorry. So basically, you can hear me, right?
Yeah.
All right, so basically, like I don't think I did it right, to be honest. But like I did a whole different way. So I took like both of the pairs, right? Like there's 1.40, basically there's two pairs. So I like added 1.40, then I got 2.80, and then like I did the 25 times 10, then I got like 250, but then I moved the decimal point, they got 2.50, and then like 2.50, like just to get towards 80, like is 30 cents more. So that's what I did. I don't think I did it right, but so I just subtracted.
You got completely lucky.
Yeah.
I see the sentiment behind what you're doing. So everybody, this is actually pretty interesting. Everybody pause for a moment. So what Kevin's talking about was, what if we had this? So if we had a problem where it said, yo, you can get 10 pairs for $50 or 10 pairs for $70. So notice how it's the same number of pairs, 10 pairs for 50 or 10 pairs for 70. And if you have the same number of pairs, then you can take the difference of the 50 and the 70 to get $20, but that's a $20 difference for 10 pairs. So then you take that 20, divide by 10, and you get 2, and that would have been the answer. Kevin, was that the route you were trying to take?
Yes. Yeah.
Yeah. So so what Kevin was trying to do was, and this is pretty smart, by the way, it just wouldn't have worked here, but it's a very smart way to think about it, because Kevin was trying to basically use a proportion here to say, yo, what if we had the same number of pairs? Let me try to get this up and this down to the same number. Unfortunately, that is going to take a little too long in this situation, but there are plenty of situations where that would apply. Plenty.
Thanks, Coach. Thanks.
Yeah, no worries. So let's go and try another one out, everybody. Let's try another one out here. So I'm going to give you all 2 minutes here. Freddie and Sesh, type your questions out. I will address them. So let's go ahead and get to this. I want to get to these last 2 questions because these last 2, I know we're going to piss some people off. So here we go. 3, 2, and 1. Let's try this out. And remember, if you are, Jalen's like, great. And if you are interested in the program, again, stay to the end. If you want to be ready for the announcement of the shirt winner, stay to the end. All right, here we go. Let's get this done here. Let's go. So Mr. Iman bought erasers shaped like sharks to give his students during Shark Week, and he spent $25.60. Everybody, what did I do wrong? Monique, no. Read the question. Read the question first. Sounds good. So let's go ahead and get back to the game show here. So how many erasers did Mr. Iman buy? That's the question there. So we have to go ahead and put our little glasses on there. That's what we want. How many erasers did Mr. Iman buy? So right there, Mr. Iman bought blank erasers. Right there. Mr. Iman bought blank erasers. Cool. Up next, what do we do? What we're going to do next is figure out what information we have that's available to help us out. Let's go. So what do we have? What do we have? What do we have? It says that he bought erasers shaped like sharks. We don't care about the shape. The problem doesn't care about the shape. Don't worry about it. It says here he spent that much money and he paid that much for each eraser. So let's write that down. We have $25.60 spent, and then 10 cents each eraser. Okay, so everybody, the key word here, exactly, David, the key word is each. It is each. Remember, everybody, the word each, the word per, for every, that can signify which two potential operations. The word each, per, for every, that can, exactly, it can signal multiplication or division. It depends on which way you're going. It depends on which way you're going. If you are moving toward getting the final total amount, we're multiplying. If we're trying to find a piece, like just the money for each eraser or the number of erasers, we're working backwards. We're dividing. Everybody, is it true that with 10 cents for each eraser, what we would be doing is multiply 10 cents times the total number of erasers to find the total cost? True or false? You do the 10 cents times the number of erasers to get the total cost. Yes. So in this case, everybody notice, we already have the total cost. So we got to work backwards to find out how many erasers. Well, we need to know how many times 10 cents fits into $25.60. Yes or no, do you all agree? Yes or no, do you all agree? Cool. So here's what we're going to do. We're going to do $25.60 divided by 10 cents. And this is the easiest problem in the world because all you have to do is this, everybody. Notice, remember how earlier I set you up for this? Move the decimal place over one time. This is the same thing as 256 divided by 1. Everybody, this is the hardest thing I've asked you to do all day. What is 256 divided by 1? Fine dining and breathing. Yeah, no, it's 256 and we are good there. We're done. 256, and that is the number of erasers purchased right there. Boom. And that's the question, or that's the answer right there, 256, and you're good. And yeah, so if you said, hey, dividing by 0.10 is the same thing as multiplying by 10, you are absolutely correct. Absolutely correct. C is correct. You guys want to try one more? All right, let's go. 3, 2, 1. Let's go. 3, 2, 1. Let's go. Last one, last one, last one. Let's go. Oh, and if you don't have, well, never mind. So here we go. Everybody, question is first, again, what was the total bill? Okay. We want total bill. We want the total bill. I don't know what they purchased. I don't know if it was dinner. I don't know if they bought a giraffe. I don't care yet. All I know is I'm looking for the amount of money that was spent total. Okay, cool. So let's go ahead then and go through the question here. And it says, Natalie and her 3 friends went out to eat. They decided to split the bill evenly. Each person paid $12.60. Sounds good. So I'm assuming here it says, okay, each person paid $12.60. Okay. $12.60. And so if we know the number of people, we just multiply the 1260 by that number and we're good, right? So Jalen, oh, thanks for answering that question preemptively, Jalen. Thank you. So my question was, how many people were there? And everybody answer the question. How many people were there? Now, if you're looking at before and you're looking at this like 3 friends, here's what happened. This is what happens when you rush the process and you don't read the story. So right here, Natalie and 3 of her friends. So that means Natalie plus 3 equals 4 total people. Very easy. Very easy. Jalen, we don't have to talk about this anymore. Just go ahead and get the program and we'll forget this all ever happened. So there we go. We have 4 people. We have 4 people, not 3. And when we multiply that together, we will receive, what's the answer, everybody? Yeah, it's going to be B. It's going to be B, $50.40 right there. So as easy as a problem might look, everybody, did we learn our lesson today? As easy as a problem might look, don't underestimate it. Do not underestimate it. To prove a point, if you guys are willing to stay the extra 2 minutes, go ahead. I'm going to give you 1 minute and 30 seconds to solve this one. Go. It's all good, Brian. I got you. I'll give you 1 minute 30 to do this one. So here, how much will the third person pay? We know that total bill is 56. So you got 56 total. If you want to find out how much the third person pays, well, you got one person pays $8. You got the next person paying 3 times that amount. So 8 times 3, that's 24. And then we have a missing amount. So all we have to do is figure out what 8 and 24 is together. That's going to be $32. So then take that 32 away and you can get 24 right away. The answer is B. So that was really, really, really quick. And I know that the majority of y'all follow along with how quickly I did that because we got so used to, again, snapping our attention to the question, then what the information says, and then what we got to do. That's improvement. That's really improvement. Because guess what? How many of y'all did this question with the utmost confidence that you knew you were going to get it right when you were done? That's what improvement is. That's what improvement looks like. It's not always going to be about, oh, I got the right answer. No, it's about how confidently you got the right answer. Can you repeat the success? All right. So we got the 24 because here it says 3 times that amount. 3 times that $8, 8 times 3, 24, man, right there.